Alright, so in this video I'm going to be going over the final exam review, and you should also be practicing on that final exam, practice final exam, because that is the best way to know what will be on your final, other than watching this video, of course. But you should be practicing on your own to see all the different kinds of problems that they can give you on that final. So the final will be covering everything that we've learned in the course, for the most part. I mean, of course, we can't test on every single thing, but we're going to focus on the most important topics that we have learned. So I've separated this final into sections. So the first section is about solving different types of equations. So there will be many different types of equations that you will need to be able to solve. So the first we're going to look at are quadratic equations. So remember that, by the way, any notes I have on here you can also put on your cheat sheet. But this one, this is the form of a quadratic equation, ax squared plus bx plus c equals 0. And this is the formula for the quadratic formula, should be equal to x. This gives the solutions to a quadratic equation. Okay, so for number 1, it's specifically telling me to use the quadratic formula to solve the equation. So Pearson, on your final exam, it'll also say this for this question. So I, copied the way that they even worded the question on the exam. So this will at least give you a hint on how to solve it. So before we use the quadratic formula, it has to be in standard form, which means it has to be equal to 0. So the first thing I would do is get this quadratic equation in standard form by adding 4 to both sides, so it'll cancel on the right. So that will leave me with 3x squared plus 6x plus 4 equals 0. And now it's in standard form, so I can now use the quadratic formula and plug in my a, b, and c. So my a is equal to 3. My b is equal to 6. And the c is equal to 4. And I got that from the coefficients here. Because of this form, a, b, and c. And then I can just plug into the quadratic formula. So x would be equal to negative b, so negative 6, plus or minus the square root of b squared, which would be 6 squared. Fix that. Minus 4 times a, which is 3, times c, which is 4, all over 2 times a. Okay, so don't forget that this is all divided by 2 times a. It's all one fraction in this equation here. Oh, and sorry, a is equal to 3, so this would be 2 times 3 here. So this would be equal to negative 6 plus or minus 6 squared is 36. Negative 4 times 3 is negative 12. And negative 12 times 4 is negative 48. So that would become negative 40 or minus 48 all over 6. And then I would keep going and simplify the 36 minus 48 under the radical. And that will give me negative 12 underneath the radical there. Okay, so now I need to simplify this radical, the square root of negative 12. Because first of all, when there's a negative underneath the square root, that means that this is going to produce an imaginary answer. And if you remember how to simplify radicals, you need to break it up into a product where one of the numbers is a perfect square root. So I'm going to do this one step at a time. The first thing I'm going to do is break it up into negative 1 times 12. Which means that this is equal to negative 6 plus or minus the square root of negative 1 times the square root of 12 all over 6. And the square root of negative 1 is equal to I. So this whole square root of negative 1 is equal to I. So that's another thing you can put on your final or your cheat sheet. So this would be I times the square root of 12 all over 6. And now 12 is equal to 4 times 3. So I'm breaking up 12 into a product where 1 is a perfect square root. And I know that the square root of 4 is equal to 2. So this will become negative 6 plus or minus I times 2 times the square root of 3 all over 6. And then let me move this over some. So this will become negative 6 plus or minus 2I times the square root of 3. I'm just rearranging them really there. And now I can simplify everything because all these terms have a factor of 2 in them. The 6 can be divided by 2, or the negative 6 I should say. The 2 can be divided by 2 and the 6 can be divided by 2. So you can only do this at the very end after you've simplified your radical completely and if they all three have a common factor. So negative 6 divided by 2 would be negative 3. So this will leave me with negative 3 plus or minus 2 divided by 2 will just be 1. So those will cancel and that will leave me with I times the square root of 3. And then on the bottom, 6 divided by 2 is still just 3. So I divided everything by 2. You have to be able to divide all 3 by 2 in order to do that. Okay, and then the final part, the final step for this one is that this is a complex number. So I need to write it in its complex number form, which I'm writing up here in the top left is a plus bi. This is complex number form. So I have to separate this into two fractions. So this would be negative 3 divided by 3 plus or minus I square root of 3 divided by 3. And now I can simplify this first fraction. Negative 3 divided by 3 is just negative 1. So this would be -1 plus or minus I square root of 3 divided by 3. This could be my final answer here, as long as I separate it into two separate terms and not leave it in one fraction. But now this is in complex form. My a, my real number, is first, which would be -1, and then my imaginary number comes second. That's also important. The order matters. So that would be my final answer. Number 2. This is a quadratic in form equation because there I see an x to the fourth and an x squared. So whenever you see a larger exponent than just 2, and the larger exponent is double the smaller one, which it is, 4 is 2 times 2, so it's double that exponent of 2, then this is quadratic in form. And the first thing I need to do is get it equal to 0. So I'm going to rewrite this equation here. So I'm going to subtract the 5x squared. So I would rewrite this in its descending order of exponents. So 2x to the fourth minus 5x squared plus 2 is equal to 0. And now this is quadratic in form. And the quadratic in form is ax to the 2 times n power plus b to the x to the n power plus c equals 0. And so when I have something like this, what I'm going to do is choose my x to the n to do a substitution. So step 2, I'm going to substitute t for x squared, because that's my x to the n, the one with the smaller exponent, x squared, up here, -5x squared. But I'm only substituting the x squared, not the -5. And if t is equal to x squared, then t squared would be equal to x to the fourth. Because if I squared both of these, x squared to the power of 2 is x to the fourth. So I need to substitute both of these into that equation. So this will become 2t squared minus 5t plus 2 equals 0. And now this just looks like a regular quadratic equation. And I can solve it like normal. So I have a that's not equal to 1. So this is the longer, harder method where I have to do the AC method. So I'm going to factor using the AC method. So I multiply a times c, which would be 2 times 2, which is 4. And then I need 2 numbers to multiply to give me 4 and add up to give me -5. Sorry, let me just write this, a times c. So two numbers that multiply to give me that 4 I just found, but they also need to add up to give me my b, which is -5. So this would be -1 and -4. So once I found those two numbers, because a is not just equal to 1, I have to replace the middle term here using my two numbers. So this would become 2t squared minus 1t minus 4t plus 2 equals 0. So I replaced that middle term there as a sum of two terms using those numbers I found as the coefficients. -t minus 4t is -5t. And now I will factor by grouping. So this is one of the methods we learned about factoring quadratics when a is not equal to 1. So on the first group, they have a common factor of t, so I pull out the common factor of t, and that'll leave me with 2t minus 1. And then in the second group, they have a common factor of 2, but because it starts with a negative in front of that 4, I'm going to pull out -2. And that will leave me with 2t minus 1. So these match like they should. So the final factored form will be 2t minus 1, the one that matches, times what's left on the outside, which is t minus 2. And then finally, I will, oops, sorry, not iPad, there we go. Set each factor equal to 0 here. To finish solving this equation. So 2t minus 1 equals 0, or t minus 2 equals 0. So after I add 1 and then divide by 2 here, t will be equal to 1/2. And I'm going to write these over here. And then for the other one, I will add 2 to both sides, so t will be equal to 2. All right, now once I get an answer for t, you have to remember to substitute back in the x squared, because I said that t was equal to x squared. So I have to now back substitute in step 3. So maybe that's a note you want to put on your flashcard so you don't forget to back substitute. So I will have x squared is equal to 1/2, or x squared is equal to 2, since that's what t was equal to. It was equal to x squared. So my two answers will be the square root of 1/2, or I'm sorry, plus or minus. So I'm going to take the square root of both of these to solve for the x. So x will be equal to plus or minus the square root of 1/2, or x will be equal to plus or minus the square root of 2. And this one will simplify because the square root of 1 is just 1. So this would be plus or minus 1 over the square root of 2. And you would have to rationalize the denominator to get the square root out of the denominator. So I would multiply the top and the bottom by the square root of 2. So this would be equal to plus or minus the square root of 2 over 2. So that would be my answer, and this would be my answer. So that's 4 answers there. Positive square root of 2 over 2, negative square root of 2 over 2, positive square root of 2, and negative square root of 2. The only reason I had to rationalize this is because there was a square root in the denominator. Okay, the next type of equation that you will need to know how to solve is a rational equation. So I gave you a reminder here of how to start solving this type of equation. You need to clear the fractions first by multiplying every term by the LCD, the least common denominator. And then you just solve from there after you clear your fractions. But you must check your answers and exclude any answers that make the denominators equal to 0. Because we cannot divide by 0. So the denominators here cannot equal 0. So first I'm going to find the least common denominator. And the way we did that, you figure out what's the, you can write down all 3 denominators here. And then 6 can be written as 3 times 2. So I'm writing it like that because it shares a factor with this denominator already, 3. And then you look at the first denominator, you include everything in the first denominator, which is a factor of 3 and a factor of x. So I'm going to include both of those in my least common denominator from the first denominator. And then I go to the second denominator. I already have an x, so I don't need another one. So I skip that. Go to the third denominator. I already have a 1, 3, so I don't need another one of those. And then finally, I'm going to add the 2. Oops. So after multiplying that together, you get 6x is the least common denominator. So that's what I'm going to multiply every term by to clear my fractions. And once when you multiply every term by the least common denominator, you're going to divide the 6x by this denominator here to see what's left. So 6x divided by 3x will leave me with just 2. And then I'll take that 2 and multiply it by the x minus 1. And then in the second one, 6x divided by x, the x's will cancel and leaves me with just 6. just write the 6 above it. And so that'll be a negative 6 because of the negative in front there, times 2. So that will leave me with negative 12. And in the last one, the 6's will cancel, and that'll leave me with the x times 5, which will be 5x. So I cleared the fractions, so now I will just solve this equation from here. So I'll distribute the 2, which will give me 2x minus 2, and then bring down the minus 12 equals 5x. Combine these like terms. Negative 2 minus 12 is negative 14. Add the 14 to both sides. Or, I'm sorry, let me back up. Well, I will need to do that, but actually, the quickest way to solve it would be to subtract the 2x. Would be the quickest way to do that, because I want to get all my variable terms to one side. So I canceled that 2x on the left and moved it to the right so I can combine those like terms. So that'll leave me with negative 14 equals 3x. And now I'll divide both sides by 3. So x will be equal to negative 14 thirds. Now remember, you must check this to make sure the denominators up here will not be 0 once you plug this in for x. But 3 times negative 14 over 3 will not be 0. And then, of course, if I just plug it into that x there, that's not equal to 0. And then the 6 is already 0. So that's my answer. It doesn't make any of those denominators 0, so we're good. The next type of equations that you'll need to solve are radical equations. So for these types of equations, you need to first make sure that the radical is isolated on one side of the equation. And then we will cancel the radical by raising both sides of the equation to the same power as the index of the radical. So if it's a square root, we'll square both sides. If it's a cube root, you cube both sides. So for this problem, the radical is already by itself on one side, and it's a square root. So I can go ahead and just raise both sides to the power of 2. So that will cancel my radical on the left, and that'll just leave me with what's underneath the radical, which is 2x plus 1. And then on the right, I will need to FOIL this out, x minus 1 times x minus 1, since it's x minus 1 squared. So I'm going to bring down the left, so that will leave me with x squared minus 2x plus 1 after I FOIL and combine like terms. And now this is a quadratic equation. Let me write FOIL. This is a quadratic equation. So now to solve the quadratic equation, I need to get everything equal to 0. So I'll subtract 2x to both sides and subtract that 1 from both sides. So this will leave me with 0 is equal to x squared minus 4x. And the 1's will cancel. 1 minus 1 is 0. So we'll just be left with this. So now I will just factor out the common factor because they both have a common factor of x. So factor out the GCF, which is x, and that will leave me with x minus 4. And then I'll set each one of these factors equal to 0. So x will be equal to 0, or x minus 4 will be equal to 0, which means x will be equal to 4. Okay, and then I guess I forgot to put it up here, but you also have to check these equations. You must check your answers. So the restrictions on radical equations is that the expression underneath the radical cannot be negative. It can be 0, that's okay. But this expression underneath the radical, the 2x plus 1 in the original, cannot be negative if I plug any of these in. But also, I need to still check, even if it doesn't make that negative, I need to check to make sure it makes the original equation true. So let me move this over. And I will bring this up here and check my work. Into the original. So first I'm going to check x equals 0. Question mark. These are just possible solutions for right now. So this would be the square root of 2 times 0 plus 1 is equal to 0 minus 1. If I plug 0 in for both of the x's into the original, 2 times 0 is 0, so that'll leave me with the square root of 1 is equal to negative 1. But the square root of 1 is not equal to negative 1. When we take the square root of 1, we only ever consider the positive one. So this is not possible. So just be careful. The square root cannot equal a negative number either. So it can't be negative underneath, and it can't equal a negative when we're solving these equations. So therefore, x cannot equal 0. Now we will check 4. So this would be 2 times 4 plus 1 under the square root equals 4 minus 1. 2 times 4 is 8, and 8 plus 1 is 9. 4 minus 1 is 3, and the square root of 9 is 3. So this one is true, so therefore the only solution is x equals 4. So you need to make sure you check your solutions for radicals because they have restrictions. Okay. The next one is solving absolute value equations. So to solve an absolute value equation, we are going to first isolate the absolute value, get it by itself, and then use the rule below to separate into two equations. So remember, if I have the absolute value of an expression and it's equal to A is positive, then either the inside of the expression will equal positive A or it'll equal negative A. But if A is negative, it'll be no solution. So anytime you have the absolute value of something equal to negative, it's no solution. So just beware of that. So for this number 5 here, I'm going to subtract 6 to both sides to get the absolute value by itself first. And that'll leave me with the absolute value of x minus 2 is equal to 11. I'm sorry, 9. And then I will use that property. So the absolute value of x minus 2 is equal to positive 9. We're okay there. So I'm going to take the expression inside of the absolute value and use it to break this up into two equations. One that's equal to the positive 9 and one that's equal to negative 9. And then I will add 2 to both sides here. So 9, or x is equal to 11. Or I will add 2 to both sides here, so x will be equal to negative 7. So those are my two solutions. I don't really have to check, or I don't have to, it's not mandatory to check the absolute value because, or the absolute value equations, because there's no restrictions except for that the absolute value can't be equal to a negative, but this is just already a number by itself, which is positive. All right, and then the next one is solving exponential equations. So this is what we just recently did in 5.5. So remember, this is this is the form of an exponential equation, which means that we have an unknown variable in the exponent. So there's two ways that we can solve exponential equations. The first is by trying to get their bases to be the same. And if we can get their bases to be the same on each side, if we have if we can get two exponential expressions on both sides where the bases are the same, then we can just cancel the exponent or the bases and set the exponents equal to each other. And that's what we're actually going to use here in this number 6, because 625 can be rewritten as a power of 5. And that's going to be 5 to the 4th power. So 625 is equal to 5 to the 4th. I'm just writing this over here. So I'm going to rewrite this equation as 5 to the 2x minus 1 power equals 5 to the 4th power. And now I've gotten the bases to be the same. So I can cancel the bases and just set the exponents equal to each other. Just 2x minus 1 equals to 4. Just like that property up there says. And then I would just solve this equation from there. So I could add 1 to both sides. And 2x would be equal to 5. And then I would divide both sides by 2. So x would be equal to 5/2. And that would be the answer. And I don't have to check these either if I don't want to. You can, using your calculator. But it's not mandatory. All right, number 7 we're going to solve this exponential equation using the properties of logs. And because this has a base e, I'm just going to go ahead and use the ln. So remember that one property that we learned that says I can take the log or ln of both sides of an equation, and it'll still be true. So that's what I'm going to do. I'm going to take the ln of the left side, which will give me ln of e raised to the negative 0.21 t power, equal to ln of 0.58. And I'm doing it this way because there's no way I can get those bases to be the same. They're decimals and it's e, so that's impossible. So I have to take the ln or log of both sides. And I chose the ln because anytime you see an e as the base, if I take the ln of e here, it just cancels. And it leaves me with that exponent. So that comes from that property of log base a of a to the x power is just equal to x. We learned this property. And ln of e to the negative 0.21 t power is the same thing as log base e of e to the negative 0.21 t power. So the bases are the same here, and that just leaves me with what's in the exponent. So that will just cancel and leave me with negative 0.21 t is equal to ln of 0.58. And then I will divide both sides by negative 0.21. So t will be equal to ln of 0.58 divided by negative 0.21. So I'm going to type that in my calculator. Ln of 0.58. Make sure I close my parentheses after the 0.58. And then divided by negative 0.21. And they want me to round to 3 decimal places. So that will round to 2.594. Okay, I'm going to stop here, and this will be part 1, and then I'll upload a part 2.